All right, last two problems for our section. So looking at this one, notice how we have a tangent in both of our terms. So in a case like this, we are allowed to factor that out if we want to. So I'm going to write this down to show you what I mean. So I'm factoring the tangent out. But if I do that in this case, it doesn't help me move forward because I can't replace this with one of my Pythagorean identities. So typically, if we are going to factor, we want to create one of these things. So that way we can replace it. So factoring in this case is not helpful. So I'm going to cross that off and I'm going to start over. So instead, I'm going to work on simplifying each term. So to do that, I'm going to start by replacing that with its reciprocal. So this would be 1 over sine theta. And then I'm replacing tangent with its quotient. So sine theta over cosine theta. And at the same time, I'm going to do the same thing here. So I'm going to replace tangent with its reciprocal. So sine theta over cosine theta. And I'm going to leave that sine theta alone. Okay. So in this group, I can cross reduce. So that leaves me with 1 over cosine theta. And then if I multiply straight across, I have a sine squared theta over cosine theta. Okay. So this worked out really nicely for us because even though we have two fractions, we ended up with the same denominator. So that means that I'm allowed to think of this as one big fraction. So I'm going to rewrite that. Okay. And now I can go and look for a Pythagorean identity. So here I have 1 minus sine squared. So again, if we do a little bit of side work, so originally it is cosine squared theta plus sine squared theta equals 1. But I want to make this one look like my numerator. So that means I'm going to have to subtract that sine squared over. So 1 minus sine squared theta. And then now I'm allowed to replace this with the cosine squared. So I'm going to replace the numerator with cosine squared theta. So that will give me cosine squared theta over cosine. And now I can simplify that fraction. So I can take away 1 cosine from each of those. And then that will leave me with cosine theta as my final answer. All right, 16. This is going to be our hardest problem, mostly because it's just hard to know what to do in this case. So usually when we have fractions, we want to try and get it into one fraction and then start simplifying it, and that's how we go from having two terms to one term. So to get it into one fraction, we need a common denominator. So our common denominator is going to be a combination of these two denominators. So our common denominator is going to be 1 minus sine theta times 1 plus sine theta. Okay. So to get this one to have this part of the denominator, we just multiply the top and bottom by that. So that means that I'm taking cosine theta times 1 plus sine theta. And I've already done that in the denominator to get this. And then I have to go through that same process for this next one. So this one's missing this part of the denominator. So I'm just going to take this part of the denominator and multiply it to the top and to the bottom. And then I need to make sure I'm keeping my minus sign in between. So this will be 1 minus sine theta. Okay. So what I'm going to do next is we're just going to simplify. So in the bottom, we are going to FOIL. And then up in the numerator, I'm going to distribute. Okay. So that is going to give us cosine theta plus cosine theta sine theta minus cosine theta plus cosine theta sine theta all over, and then I'm foiling this, so that will be 1, and then plus sine theta, minus sine theta, and then minus sine squared theta. Okay. And now I'm just going to start combining like terms. So in the denominator, these two things cancel out. In the numerator, the cosine thetas cancel out. And then I have 2 of these groups. Okay. So in the numerator, I'm going to have 2 cosine theta sine theta over 1 minus sine squared theta. Okay. So looking at this in my denominator, I should immediately be able to recognize that as a Pythagorean identity, one that's rearranged, so it's going to be this one. So I'm going to replace my denominator with cosine squared. So 2 cosine theta, sine theta on the top still, and then the denominator becomes cosine squared theta. Okay. So since I have all multiplication up in the numerator, I'm allowed to reduce. So I can cancel out this cosine and then 1 from the denominator. So now this will simplify to be 2 sine theta over cosine theta. And then sine theta over cosine theta is a quotient identity, so I can replace that with tangent, and then I just have to keep that 2. So 2 tangent theta is going to be my final simplified answer for this problem. And that will also conclude this section.